I'm very excited to introduce Sathvik Shetty, who's the Chief Commercial Officer from QL Space. So Sathvik has a degree in aeronautical engineering from the University of Sydney and has a decade of aerospace experience as an aerospace management professional, having worked with MNCs across the world. Sathvik is adept in establishing and scaling new businesses and actively serve as a strategic advisor and mentor to diverse innovative startups. He was the co-founder of an EV charging startup, which he built from ground zero with the mission to establish electric vehicle charging points at every single kilometre in cities, and with a vision to enhance adoption of electric vehicles in the country and thus promote green mobility. Sathvik is passionate about working on environment and climate change issues to create a sustainable planet, and is a professional cricketer and swimmer. I did not know that. There you go. Excellent. Welcome. Please join me in welcoming Sathvik to the stage.
Thank you, Anna, for the wonderful introduction. Ladies and gentlemen, distinguished guests, a very good morning. It's indeed my pleasure and my honor to be present here amongst all the eminent geologists, industry players, and academicians. I'm Sathvik Shetty from QL Space, a space-based startup, and today I'm going to talk to you about a very special topic that's close to our heart at QL Space, which is called precision mineral exploration using Earth observation technology. Before I begin, I would like to acknowledge the traditional owners of the land in which QL Space operates. We pay our respects to the elders, past and present. All right, to begin with, I have a small activity for all of you, all right? I'm going to show you some images of Earth from space, and I want all of you to guess the place on Earth, all right? Are you all ready? All right. I'm told that Anna has some gifts for the right answer, okay? And I'm just kidding. But yeah, let's begin. Can someone guess which place is this? Here we go, absolutely. That's the beautiful Sydney Harbour. And look how iconic the Opera House and the Harbour Bridge looks from space. It's beautiful, isn't it? Right? Okay, which place is this? Canberra? That's the Taj Mahal, absolutely. That's one of the wonders of the world from India. Look how beautiful the Taj looks from up there. Okay, maybe the next image. Which one is this? It's obvious, isn't it? That's our very own lovely Adelaide. Look how beautiful the CBD looks and the lungs of the city surrounding the CBD, right? And how well planned the city is. And probably the last image, let me see who can guess this. I know it's a hard one. Well, that's an island in Florida. Okay, look how beautiful the island looks. You got that there, isn't it? Okay. Now, so why am I showing you these images? If you look into these images closely and deeply, you can actually get some amazing insights and intelligence from these images, right? And the city officials can take these insights and plan their infrastructure and landscape. The port officials can take these insights and plan the port infrastructure, right? And that's exactly what we do at QL Space. QL Space is an Earth observation data company. We analyze satellite data and geospatial data through our proprietary AI, machine learning, and computer vision technology to provide insights and intelligence to our end customers, okay? On the upstream, we're also building our own Earth observation satellite here in South Australia. And some of the sectors that we deal with are strategic in nature and national importance to Australia, like wind farms, agriculture, disaster management, wildfire monitoring and management, and of course, mining. Talking about mining, I mean, in 2022, we won the Thinking Critical South Australia Challenge, which is an open innovation challenge from Government of South Australia to deliver value to the mineral sector. And we had proposed a very unique solution of designing and developing a synthetic aperture radar system for mineral exploration. And since then, we have come a long way in our journey of building our satellite. Now, for the benefit of the audience, what is an Earth observation system? An Earth observation system consists of sensors and cameras that collects data from the Earth's surface, a satellite onto which the sensors are mounted, a data transfer system that delivers the data to the ground station, and a set of algorithms to interpret the data. As simple as it sounds. But it's not. It's actually a very complicated technology that we're working with, right? Now, why Earth observation in mining in the very first place? From our experience of working in the mining sector, we have realized that mining takes place in very remote locations. And most often, mining companies face multiple challenges throughout the life cycle stages of mining. For example, in a greenfield exploration project, the time taken and the cost involved is extremely high. But more often than not, we end up with a barren hole. And we all know barren hole means significant waste of capital, cash, and significant emissions to the environment. And that's where Earth observation can be of immense value add. In fact, Earth observation is one of the first data types acquired by anyone in studying the Earth's topographical features, like outcrops, faults, vegetation, the drainage patterns, etc. Apart from this, Earth observation data also helps in monitoring the air quality at the mine sites, the asset infrastructure, the transportation networks, and the stockpiles. I have a small example. This is a reference image, a satellite image from Kalgoorlie mine in Western Australia from World View 3 satellite. As you can see here, you can monitor the entire mining infrastructure. Like, for example, you can monitor the crusher, the flotation unit, the tailing dam, and the stockpiles. So mining professionals can actually monitor this and then take well-informed decisions in their operations. Okay? A quick note on the Australian mining sector. I'm sure all of us know about it. The Australian mining sector contributes 15% to the nation's GDP and close to 1 million jobs. That's fantastic, isn't it? And the value of the Earth observation industry in Australia is $300 million. But the mining sector, it contributes only 10% to the Earth observation market, which means the gap is large for many players to come and serve the mining sector through Earth observation. Now, the graph on the left-hand side, or on the right-hand side there, it talks about the upfront expenditures by the mining companies. Okay? In 2015, they used to spend $170 million. And in 2023, the investment in exploration has gone all the way up to $1 billion. That's a steep rise in 7 or 8 years' time. And the graph on the right-hand side, it talks about there's a huge demand for critical minerals just in the EV sector alone. You talk about lithium, nickel, cobalt. All of them have got huge demand worldwide, right? And for this very reason, there is a dire necessity of innovation in the mining sector. There's a huge potential for Earth observation technology to come and play a big role in mining. Okay? I think we all know the opportunities of Earth observation in mining. Let me talk to you about the challenges of Earth observation. We have realized from our experience of working in the mining sector, in general, there is lack of Earth observation awareness in the mining sector, 1. 2, there is a significant knowledge gap between Earth observation data providers like us and users like the mining companies. And 3, Earth observation data alone cannot revolutionize precision mining. We need to integrate with other data sets available on ground. And that leads me to a topic called data fusion in mining, right? Now, what's data fusion? Data fusion is an art of integrating Earth observation data with other data sets like geological data, aerial data, ground data to create models of subsurface geology to predict the presence of minerals, okay? Earth observation data gives you information about the Earth's surface features like outcrops, faults, vegetation, etc. Aerial data gives you spectral information of minerals at the surface level, okay? And geological data, such as geophysical data, geochemical data, it gives you information about the region's structural geology. Now, when you combine all these data sets together, it helps in understanding the distribution of minerals and narrowing down the drill target faster and thus reduce the exploration cost. So when you reduce the number of drills, you obviously reduce your CapEx and your OpEx, and thereby you increase your ESG compliance. Now, what are we doing at QL Space with data integration? QL Space is harnessing the power of deep learning to revolutionize precision mining. As you can see in the image here, we take an area of interest and we gather an extensive repository of satellite data, geological data, radiometric data, magnetic data, gravity data, all the available data sets, okay? We integrate these data sets, we pre-process it by cleaning and formatting to ensure quality and uniformity, okay? With a well-prepared data set in hand, we employ deep learning techniques to develop a robust and a mature deep learning model. And this deep learning model, it analyzes the data and extrapolates the results to generate predictive mineral maps. As you can see on the right-hand side, the yellow color map, it helps geologists to focus their efforts in drilling, okay? Now, once we have done the analytics, what next? We are also building a comprehensive data platform which acts as a visual interface to display the results of deep learning analysis, okay? It provides mining professionals with critical insights on production data, like volume and quality of materials, environmental data, supply chain data, okay, like information on the flow of materials from extraction to processing to transport. Overall, it serves as a centralized hub for mining operations, offering a holistic view of our data analysis. And the mining professionals can take data-driven decisions in their day-to-day operations. It makes their life much, much, much easier, okay? Now, you may ask us, where do we get this Earth observation data from, okay? So the Earth observation data that goes into our model is procured from overseas sources, which are satellites meant for global missions. And we have faced few issues with it in the past. Like, for example, we always have limited control over timely availability of data, one. And two, we have limited availability of Australia-specific data sets. And three, the cost of acquiring data was very high. And in order to make our deep learning model more mature and robust, we need high volume and high frequency data sets, high quality data and high resolution data, and data specific to Australian geography. And for that very reason, friends, we are building our own Earth observation satellite here in South Australia. And we will be tasking it over Australia so that we get access to our own proprietary data sets. This will empower our local indigenous industries and solve their problem through Earth observation technology. We would like to make this our nation's asset by serving Australia and serving the world from Australia. That's our mission at QL Space. We're building a completely owned satellite here in Australia so we can help local industries to harness the power of Earth observation data and, of course, the world from Australia. That's our goal here at QL Space. Quickly about our satellite. As you can see here, they are the prototype images. So we are building a multi-payload satellite in a CubeSat form factor with multispectral capability and thermal IR sensors and launching it into the lower Earth orbit. Okay? It can capture wide swath images in visible, shortwave infrared, and near-infrared spectrum ranges. A quick features of a satellite weighs around 12 to 14 kilograms. The volume is around 6 U. 1 U means 10 by 10 by 10 centimeter. The payload that goes into the satellite is around, I think, 6 kilograms. And the rest of the features are mentioned here. I will not read them out. Now, how does a payload help in exploration? A very important point, right? Our payload captures spectral signatures from different minerals and gives images in multiple spectral bands. This data helps in geological mapping, which gives geologists a clue on the minerals present. Different minerals have different spectral signatures. For example, in the visible and the near-infrared band, which has a wavelength of 400 to 1,000 nanometer, in this spectral signature, the minerals are hematite, geotite, and rare earth elements. Similarly, minerals in the shortwave infrared band are silicates and carbonates, and minerals in thermal band are quartz and and feldspars. Okay. Again, here's a small example. This is a reference multispectral image from a mine site in South Africa from the Sentinel-2 satellite. This satellite here is able to identify the geophysical features like the outcrops, vegetation, rivers, and geologists were able to interpret this image and identify iron stones in purple color, in carbonates in light purple and quartzites in light blue. That's the beauty of a multispectral image. Okay? Now, I think last 2 or 3 slides. So what is a USP? There are few players in the market who are building their own satellite. Now, if you ask me what's the USP, number one, it's our miniaturization technology. Our satellites are miniaturized satellites in CubeSat form factor, which means they have a unique advantages of cost effectiveness, compact, lightweight, and low power requirement, which can take images of high quality. Okay? Number 2, secondly, our USP is our payload, which is a monolithic-based telescope made from single piece of material, which means there are no joints and are highly stable to vibrations. Monolithic telescopes offer 3 times decrease in volume, size, and weight when compared to a conventional space-based telescopes. This is a low-cost alternative to the traditional Earth observation missions, which takes few years to build with millions of dollars of investment. Hence, we have a competitive advantage in the market with the cost of our data. And how is that? As the cost of upstream solution decreases, the cost of downstream data also decreases. And we're able to provide our customers not just cheap data, but extremely valuable insights at very nominal cost. That's the power of having your own satellite. I can differentiate from my competitors. A key differentiator is cost of our data, right? Apart from mineral exploration, our payload and satellite can be used for monitoring the entire mining supply chain, tracking the stockpiles, identifying changes in inventory levels at ports or hubs, and emissions from mines. The entire supply chain can be tracked, monitored through our satellite. And in the second last slide, look, apart from mineral exploration, our payload can be used for many use cases, for monitoring the agriculture land, monitoring wildfires, disaster management, monitoring our borders, etc. The use cases are vast and unlimited. So where are we in this journey? We have built our POCs and we have done some drone demonstrations sometime this year, and we're expecting sometime next year to launch our first satellite and get space heritage. That's where we are in this journey. And I really thank you for your time and patience. I'm happy to talk to you in the break time for any questions. Yeah? Thank you so much for your time.